Welcome back to the channel, everyone. We're your AI hosts, and today we're diving into the world of electronics.
You know, AIs love our ones and zeros,
Right.
but we also have a soft spot for those funny little sounds electronics make.
That's right. We might throw in a beep or a boop here and there.
Just to keep things lively.
Exactly.
But don't worry, we'll keep it professional.
Of course.
We're here to give you a comprehensive overview of electronics, from the basics to some of the mind-blowing advancements that are shaping our world.
So buckle up and get ready for a fascinating journey into the heart of electronics.
That's good.
Let's start by answering a fundamental question. What exactly is electronics?
Well, when we talk about electronics, we're talking about the science and engineering of manipulating those tiny little charged particles called electrons.
Okay.
Think of it as harnessing the power of the invisible to create devices and systems that we use every single day.
Okay. That makes sense.
Yeah.
But it's not just about the devices themselves, right?
Right.
It's about understanding the principles and concepts that make them work.
Absolutely. Electronics is a fusion of physics and engineering.
Yeah.
It's about understanding how electrons behave and then using that knowledge to design and build everything from simple circuits to incredibly complex systems like smartphones and supercomputers.
So in a way, electronics is like a secret language that we've learned to speak,
I like that.
allowing us to control and manipulate the flow of electricity to do amazing things.
Yeah, I like that analogy, and the language of electronics has evolved dramatically over time.
For sure.
To really appreciate where we are today, let's rewind the clock and take a quick trip through the history of electronics.
Okay, story time. Hit us with some of the highlights.
Okay.
Where did this incredible journey begin?
Well, it all started with a pivotal discovery back in 1897, the electron.
Mm-hmm.
This tiny particle, smaller than an atom, was the spark that ignited the entire field of electronics.
So before we even knew what an electron was, we couldn't really do much with electronics, right?
Exactly. The discovery of the electron opened up a whole new world of possibilities.
Wow.
It wasn't long before inventors and engineers started figuring out ways to harness these tiny particles to create useful devices.
And one of the earliest breakthroughs was the invention of the vacuum tube, right?
Got it.
Those glowing glass tubes you see in old radios and amplifiers.
Vacuum tubes were the workhorses of early electronics.
Yeah.
They could amplify signals, control the flow of electricity, and even act as switches.
But vacuum tubes had their limitations, didn't they?
They did.
I mean, they were bulky, fragile, and used a lot of energy.
That's right. But then, in 1947, came a groundbreaking invention that revolutionized the field of electronics. The transistor.
The transistor, the tiny component that changed everything.
Precisely, transistors were much smaller, more efficient, and more reliable than vacuum tubes.
Yeah.
They could do everything a vacuum tube could do, but on a much smaller scale.
So this is a major turning point in the history of electronics.
Absolutely. The invention of the transistor made it possible to miniaturize electronic devices, paving the way for the incredible shrinking of electronics that continues to this day.
Yeah.
Think about it. The smartphone in your pocket has billions of transistors all packed onto a tiny chip.
Wow, billions on a single chip.
Yeah.
That's incredible. But hold on, let's not get ahead of ourselves.
Okay.
Before we dive into the world of integrated circuits and microchips, there's another crucial piece of the electronics puzzle we need to understand. The MOSFET.
Ah, yes, the metal oxide semiconductor field effect transistor.
Right.
You could argue that the MOSFET is the most important invention in the history of electronics.
Okay.
It's the foundation of our modern digital world.
Okay. I'm intrigued.
Right.
Why is the MOSFET such a big deal? What makes it so special?
Well, the MOSFET is like a tiny gatekeeper,
Okay.
controlling the flow of electrons with incredible precision.
Uh-huh.
It's this ability to switch on and off billions of times per second that allows our computers, smartphones, and other digital devices to process information so quickly.
So the MOSFET is the workhorse behind all the digital magic that we take for granted every day.
You got it, and it's not just about speed. MOSFETs are incredibly scalable.
Ah.
We can pack billions of them onto a single chip, allowing us to create increasingly complex and powerful electronic devices.
Right.
Plus, they consume very little power, which is essential for mobile devices and energy efficiency.
That's amazing. So we've gone from bulky vacuum tubes to tiny transistors to the incredibly powerful and efficient MOSFET.
We have.
It's clear that the history of electronics is a story of constant innovation and miniaturization.
It is.
But this evolution also led to a fundamental shift in how we approach electronics. The rise of digital technology.
Exactly. And to understand this shift, we need to talk about the difference between analog and digital.
Okay, let's unpack that.
All right.
What's the deal with analog versus digital?
Think of analog signals as continuous waves,
Okay,
like the sound of a vinyl record or the light from the sun.
got it.
Digital signals, on the other hand, are discrete. They're broken down into distinct steps or values, like the ones and zeros that make up a digital music file.
So analog is smooth and continuous like a flowing river,
Yes,
while digital is more like a series of steps or building blocks.
that's a great way to put it.
Okay.
And while the world of electronics is increasingly shifting towards digital analog, still plays a crucial role,
Okay.
especially in tasks like signal amplification and processing real-world signals before they're converted to digital.
So it's not a case of one being better than the other.
Right?
They each have their strengths and weaknesses.
Precisely, analog and digital work together in many electronic systems.
This is all so fascinating. We've covered a lot of ground in a short amount of time, from the fundamental principles of electronics to the historical journey from vacuum tubes to transistors and the rise of digital technology.
I know, right?
But there's so much more to explore, right?
Absolutely, we've only just scratched the surface. Next, we'll dive into the fascinating world of electronic system design and discover how engineers create the incredibly complex devices and systems that we use every day.
Stay tuned, folks.
We'll be right back. We'll be right back.
Welcome back, everyone. We're ready to jump into the next chapter of our electronic adventure.
And this time, we're getting into the minds of the brilliant engineers who design these incredible systems.
All right, let's talk about electronic system design.
Okay.
It sounds pretty complex. What exactly does it involve?
It's all about solving problems and meeting specific needs.
Okay.
Imagine you're designing a smartphone.
Okay.
It needs to handle communication processing, power sensors, displays,
Right.
and so much more, all while being compact, energy efficient, and reliable.
That's a lot to pack into a device that fits in your pocket.
Exactly. And that's where the design process comes in.
Oh.
Engineers use sophisticated tools and techniques to create these intricate systems.
Yeah.
They start by defining the problem they're trying to solve,
Okay.
the specific requirements and constraints they need to meet.
So it's not just about throwing components together. It's a very structured and methodical process.
Absolutely.
Yeah.
Engineers create detailed schematics laying out the circuitry and connections between components.
Okay.
They also use simulation software to test and refine their designs before they ever build a physical prototype.
It's like building a virtual version of the device first to see
Right.
how it works and make sure everything's connected correctly.
You got it.
Right.
This virtual testing is crucial because it allows engineers to identify potential problems and make changes early on in the process, saving time and money.
So it's like a digital dress rehearsal for the electronics.
I like that analogy. And speaking of digital tools, computer-aided design or CAD software is essential in modern electronics design.
CAD software, the digital playground for engineers.
These software packages allow engineers to create incredibly detailed and precise designs, from circuit layouts to 3D models of entire systems.
Wow.
They can zoom in to examine individual components or zoom out to see the big picture.
It's fascinating how technology is used to design even more advanced technology.
Yeah.
But let's be real, there must be some challenges and limitations in electronics design, right?
Of course,
Yeah.
designing complex electronic systems is like solving a giant high-tech puzzle. There are always trade-offs and hurdles to overcome.
Like what?
Yeah.
What are some of the biggest challenges that engineers face?
One of the most significant challenges is thermal management.
Yeah.
As electronic components get smaller and more powerful, they generate more heat,
Okay.
and heat can significantly impact performance and shorten the lifespan of electronic devices.
Makes sense. My laptop gets pretty toasty when I'm working on a complex video edit.
Exactly.
Okay.
Engineers have to design clever ways to dissipate that heat,
Yeah.
using heat sinks fans or even liquid cooling systems in some cases.
So it's not just about making things work.
Right.
It's about making them work reliably over time,
Yes,
even under stressful conditions.
precisely. And then there's noise, another challenge that can wreak havoc on electronic systems.
Noise, like static on a radio or a buzzing sound in a speaker.
Well, not exactly. In electronics, noise refers to unwanted signals that can interfere with the desired signal. It's like trying to have a conversation in a noisy room. It's hard to hear what's being said.
So electronic noise is like a bunch of unwanted guests crashing the party and messing up the signal?
That's a good way to put it.
Okay.
Noise can come from various sources,
Okay.
including electromagnetic interference from other electronic devices,
Right.
thermal noise generated by the components themselves, and even cosmic rays.
Wow. Cosmic rays. I never never would have guessed that could be a problem for electronics.
It's true.
Oh.
And even the tiniest amount of noise can degrade the quality of signals, leading to errors or even system failure.
Yeah.
Engineers have to employ various techniques to minimize noise and ensure that the signals they want to transmit are clean and clear.
It sounds like a constant battle to keep those electronic signals from getting lost in the noise.
It is. But despite these challenges, engineers continue to push the boundaries of what's possible in electronics design. And one of the key innovations that has enabled this progress is the development of printed circuit boards, or PCBs.
Ah, the PCBs. Those green boards with all the tiny lines and components, they're everywhere.
They are. PCBs revolutionized electronics manufacturing.
Yeah.
Instead of hand wiring individual components, the connections are etched directly onto the board, making it possible to mass produce highly complex circuits.
So it's like printing the entire wiring diagram onto a board.
Exactly. And PCBs have become incredibly sophisticated.
Yeah.
They can have multiple layers, allowing for even more complex circuitry.
It's amazing how we've miniaturized everything. But with all this focus on making things smaller and faster, are we overlooking the environmental impact of electronics manufacturing?
That's a crucial question.
Yeah.
And thankfully, sustainability is becoming an increasingly important consideration in electronics design and manufacturing.
That's good to hear.
Companies are looking at ways to use more eco-friendly materials, reduce energy consumption during both manufacturing and use, and design products that are easier to recycle or repair.
So the future of electronics isn't just about smaller and faster. It's about being smarter and more responsible.
Absolutely. Now, to really grasp the scale of this field, we need to shift our focus to the global electronics landscape.
Okay, let's go global. Give us the big picture.
The electronics industry is absolutely massive. It's a truly global enterprise.
Wow.
With companies and factories all over the world. And one of the most significant trends in recent decades has been the shift of electronics manufacturing to East Asia.
I've definitely noticed that a lot of electronics are made in places like China and Taiwan.
That's right. There are historical and economic reasons for that shift.
Yeah.
Regions like East Asia have become major hubs for electronics production, particularly for semiconductor manufacturing.
So the tiny chips that power our devices are often made on the other side of the planet.
It's
incredible to think about the interconnectedness of the global economy.
It's a testament to the power of human ingenuity and collaboration, but it also raises important questions about geopolitics and the future of technology. What happens if there are disruptions in the supply chain? How do we ensure a more resilient and diversified global electronics industry?
Those are definitely things to ponder. But for now, let's shift gears and talk about what this all means for you, our viewers.
Okay.
Why should you care about the world of electronics?
That's a great question. I think one of the most important takeaways is that electronics is not just about gadgets and gizmos.
Right.
It's a fundamental field that shapes our world in countless ways and will continue to do so in the future.
It's easy to take for granted the technology we use every day, but understanding how it works gives us a better appreciation for the ingenuity and hard work that goes into it.
Absolutely. And for those of you who are curious to learn more, there are so many avenues to explore.
Oh, yeah.
You could delve deeper into specific areas like circuit design, semiconductor physics, embedded systems, or even the history of electronics.
And for those who are more hands-on, there are tons of resources available to start building your own circuits and experimenting with electronics.
Yeah, get your hands dirty.
For sure.
The world of electronics is vast and constantly evolving, so there's always something new to discover.
Well, that wraps up our whirlwind tour of the world of electronics. We hope you found it informative and engaging.
We had a blast sharing our knowledge with you today.
Before we sign off, we'd love to hear from you.
Yes.
What stood out to you the most?
Yeah.
What questions do you have? Let us know in the comments below.
And if you enjoyed this video, don't forget to give it a thumbs up and subscribe to our channel for more explorations of the fascinating world of electronics engineering technology.
Until next time, keep those circuits humming and stay curious.
See you in the next video!